Okay, so in this video, we're going to be talking about the quadratic formula and how to use it. Now, when you use the quadratic formula, you're essentially trying to find the zeros of a quadratic. Now, the zeros are where it crosses the x-axis, and typically when you're trying to solve for the zeros of a quadratic, your first step is to try to factor the quadratic. Now, not all quadratics can be factored, and that's why we use the quadratic formula. Now, if you didn't know, the quadratic formula actually comes from completing the square. And I actually have a whole video on deriving the quadratic formula by using completing the square. So you want to know where this actually comes from. You don't want to just be using these formulas blindly, because once you have a deeper understanding of it, you're going to be able to apply it in ways that others will not be able to apply it because they do not have a deeper understanding of it. So make sure you check out that video of deriving the quadratic formula. I will go ahead and link it below. But with that being said, let's talk about how we're actually going to apply it to find the zeros. So again, you use the quadratic formula as the default. When factoring doesn't work, then you resort to the quadratic formula. And I mean, technically you could do completing the square as well, but most students are going to default to the quadratic formula, okay? Now, we have it written right down here, negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? So it's pretty straightforward. We just want to make sure that we label all of our coefficients when doing these problems. So for example, we have our quadratic in standard form right here. And when you're using the quadratic formula, you want to make sure that you identify what your A coefficient is, your B coefficient, and your C coefficient or your constant, okay? So every time you do these problems, you want to go ahead and label those out. That way you know exactly where they are and you know exactly what to use, okay? One more thing before we start our problems, make sure the quadratic is set equal to 0. Before you can use the quadratic formula, you have to make sure that the quadratic is set equal to 0, okay? So with all of that being said, let's take a look at our first problem. Okay, so here's our first example, and you can see that our quadratic is not set equal to 0. So that's what we need to do first, meaning I need to take this 8x and I need to move it over to the left-hand side. So we're going to go ahead and rewrite it. We will get x squared minus 8x minus 48, right? All equal to 0. Again, just moving that 8x over to the left-hand side by subtracting it. Now we can list out our coefficients a, b, and c. So my A coefficient here is going to be 1, so A is equal to 1, B is going to be equal to negative 8, and C is going to be equal to negative 48, okay? So again, make sure that you set the quadratic equal to 0 before listing out your coefficients. Now we can go ahead and plug it right into the formula, and I actually wrote that formula right down here in case you forgot. Now remember, that formula is technically equal to x being the zeros of the quadratic, so just keep that in mind. So when I write out this formula, I'm actually going to write x equals, okay? So doing that, we are going to get x equals, the first part is negative b. Now my b is negative 8, so when I plug it in, it becomes positive 8. So I get 8 plus or minus square root of, now I have to do b squared. Well, for me, that's going to be negative 8 squared. And I'll go ahead and just write it in for now. You may be able to do that in your head, but we'll write it all out. And we get minus 4 times a. Now my a is going to be 1. My c is going to be negative 48, okay, all over 2a. So my a is 1, so 2 times 1, I'm just going to write 2 here, okay? Now we can clean up what we have underneath the square root. So why don't we go ahead and do that? So we get x equals 8 plus or minus the square root of negative 8 squared is 64, positive 64. And then you have a negative 4 times 1, so that's negative 4. And then negative 4 times a negative 48 will give you positive 192. So plus 192 all over 2. So now just cleaning it up even further, we get x equals 8 plus or minus square root of, when you add 64 and 192, you get 256. So you get 256 all over 2. Now, 256 is a perfect square. When we take the square root of 256, we get 16. So we get x is equal to 8 plus or minus 16 all over 2. I mean, technically you're done here, but we're going to break it down into its individual parts. So I have to do 8 plus 16. That is going to give me 24. And then 24 divided by 2, I get 12. So x is equal to 12. Okay. And then the other part, I have to do 8 minus 16. That gives me negative 8. Negative 8 divided by 2, I get negative 4. So x is equal to negative 4. And so that's done. We just solved the quadratic by using the quadratic formula. Again, these values are telling you where it's crossing the x-axis. So this quadratic is crossing the x-axis at 12 and negative 4. Okay? Let's go ahead and try another example. So here's our next example and take a look at it. Is it equal to 0? And it is. So now we can start listing out our coefficients. My a coefficient is going to be negative 1. So I put negative 1. My b is going to be positive 4. So b is equal to positive 4. And c is going to be equal to 12. Okay? So from here, we're going to go ahead and plug it in. So first, I have to write x equals. And now negative b. Well, my b is 4, so negative 4. Plus or minus square root of b squared. I'm just going to go ahead and write it. It's going to be 16. 4 squared is 16, right? Minus 4. My a is negative 1. My c is positive 12. Okay, all over 2 times a. That will give me negative 2. 2 times a negative 1, negative 2, right? Now let's clean up what we have underneath the square root. So we have x equals negative 4 plus or minus the square root of 16. Now doing this part here, negative 4 times a negative 1, that will give you positive 4. And then 4 times 12, you get positive 48. So plus 48 all over negative 2. So let's continue with the problem. We get x is equal to negative 4 plus or minus the square root of 16 plus 48, you get 64, another perfect square, all over negative 2. And now rewriting it, we get x equals negative 4 plus or minus square root of 64 is 8, all over negative 2. And then breaking it down into its individual parts, we get negative 4 plus 8. That will give us positive 4. Divided by a negative 2, we get x is equal to negative 2. There's one of the zeros. Doing the other one, we get negative 4 minus 8, we get negative 12. Negative 12 divided by a negative 2, we get positive 6. There's the other 0. Okay, done. So this quadratic is crossing the x-axis at negative 2 and positive 6. And you actually could have factored this quadratic. You didn't have to use the quadratic formula. And actually, you could have factored the other problem as well. Okay, so actually problem 1 and this problem here, you actually could have factored. But the next one you cannot factor. You definitely have to use the quadratic formula. So let's go ahead and take a look at that one. So here's our next problem. And I told you, you are going to have to use the quadratic formula no matter what. If you do try to factor it, it's not going to be like the first 2 problems where you could have gotten away with factoring. This one, you're definitely going to have to use the quadratic formula. So our first step, we have to set it equal to 0, meaning I have to take this negative 6 here and move it over to the left-hand side. I'm going to have to add 6, okay? So doing that, I get the following. I get negative 6x squared, and I'll get plus 11 here, okay, equal to 0. All right, now we can list out our coefficients. A is going to be negative 6. B is going to be, well, I don't have a B, so it's 0. And then C, my constant, is 11. So plugging it in, we get x is equal to negative b. Well, my b is 0. So technically, I don't even have to write anything there. I can just go on to the plus or minus part. So I'm going to write plus or minus square root of b squared. Again, it's 0. If you want to put 0 there, go for it. Technically, you don't have to. I'm not going to write anything there, okay? So I'm going to go on to negative 4ac. So I have negative 4. My a is going to be negative 6, and my c is going to be positive 11, okay? All over 2 times a, that will give me negative 12, right? 2 times a negative 6, I get negative 12. So this one's actually not too bad. We just have to clean up that square root, and we're pretty much done. So if I do negative 4 times a negative 6, I get positive 24. And then 24 times 11, I get 264. So I get x is equal to plus or minus square root of 264 all over negative 12. Now, technically, that is done, but we should see if we can break down this square root here. Maybe we can keep simplifying it down, okay? So we're going to do that by using prime factorization. So off to the side here, we're going to write the square root of 264, and we're going to use prime factorization. So I need 2 numbers when I multiply. That will give me 264. And I can actually use 8 and 33 here. So I'm going to use 8 and 33. And again, you want to break everything down into its prime factors. So starting with 33, I could do 11 and 3. Those are both prime. I'm done there. On 8, I can use 4 and 2, and then 2 and 2. So technically on this one here, I can pull out a 2, okay, because I have a pair of 2s. And then my prime factors that are going to stay underneath the square root are going to be 2, 11, and 3, okay? Or in other words, 66. You're going to end up multiplying them all together, okay? So the 2 comes out, and then I have 66 underneath the square root. So I'm going to write x is equal to plus or minus, again, I'm going to pull out a 2, and then I have the square root of 66 all over a negative 12. And I'm almost done here. And this negative right here is technically meaningless because I already have plus or minus right here on my numerator. So it really doesn't matter. I know that my end result is going to be plus or minus, so I don't really even have to worry about the signs here, okay? I just have to reduce the 2 and the 12. I know that 2 goes into itself 1 time and 2 will go into 12 6 times. So I can write x is equal to plus or minus square root of 66 all over 6. And if you really wanted to, you could break it down into its individual parts, which would be x is equal to the square root of 66 all over 6. And then the other part would be x is equal to negative square root of 66 all over 6. And again, that would be the 2 zeros for this quadratic, okay? So this problem is done. Again, you can leave it like this here if you want. That's totally fine. But that is how you solve a quadratic using the quadratic formula. So remember, the quadratic formula should always be the default. It shouldn't be something you use all the time. You should always try to factor a quadratic because factoring is actually quicker. So like on those first 2 problems that we did in this video, you actually could have factored it, okay? And so if you're having trouble factoring, I actually have videos on that. I teach the AC method when I'm factoring quadratics. So make sure you check out those videos. I will link those below as well. And that's pretty much it. So if you gained anything from the video or the video helped you in any way, please go ahead and give it a thumbs up. Also, make sure you subscribe to this channel so you get more math videos in the future, and I'll see you in the next one.